All right, in this problem, what we're going to do is we're going to complete the square to just help us describe what the graph of this particular quadratic looks like. And then we're going to actually graph it on our graphing calculator to double check that we are correct. So the first thing I'm going to do is I'm going to take the quadratic function, I'm going to rewrite it in standard form so that it is in descending order and so that it is in the form of ax squared plus bx plus c. So right now I'm going to ignore the f of x and I'm going to write it as negative x squared plus negative 16x or minus 16x, it doesn't matter, plus 10. And when I'm completing the square, normally my first step is to write it as ax squared plus bx equals c. So what I'm going to do is I'm going to move this 10 over to the other side, and I'm going to have negative x squared plus negative 16x is equal to negative 10. You may also have, if you prefer, negative x squared minus 16x equals negative 10. The next step is, when you are completing the square, is that a has to equal positive 1. In our case, a is equal to a negative 1 right here. So what we need to do is we need to factor out on the left-hand side here, we're going to factor out a negative 1. So if I factor out a negative 1, I'm going to put negative 1 on the outside of the parentheses, and I'm going to have x squared plus 16x in the inside equals my negative 10 still. The third step when completing the square is to take the middle term, which is the b, divide it by 2, and square it. So for my purposes, the middle term here is 16. So 16 divided by 2 is 8, and if I square 8, I get 64. So normally what we do is we add 64 to both the left side and to the right side. And so what I'm going to go ahead and do is on the left-hand side, I'm going to add 64 to my parentheses. So I have negative 1 parenthesis x squared plus 16x plus 64. And what I'm going to do over here on the right-hand side is I'm going to also add negative 64. However, because you factored out an a, and this is where a lot of people mess up, when you factored out an a to make the a equal to a positive 1 up above, our factor out here is negative 1. So if I redistribute that negative 1 back through these parentheses here, this is really negative 1 times 64 on the left-hand side. So over here on the right-hand side, when I add 64 to this side, I'm going to add 64 times the a that I factored out, which in this case is negative 1. So on the right-hand side, really what I have here is I have negative 10 plus negative 64 for a negative 74. Okay, on the left-hand side, I still have negative 1 times x squared plus 16x plus 64. My next step is to then factor this left side in the parentheses here, and it'll factor into my perfect square trinomial into x plus 8 quantity squared equals my negative 74. So finally, my last step is to take the negative 74 back over to the left, and so my function is going to be f of x equals negative 1 parenthesis x plus 8 quantity squared plus 74. Okay, let's talk about what all this means then. In our function, for our general function for vertex form of a quadratic, f of x equals a times x minus h quantity squared plus k. What the following tells us is that the a, if it is positive, I have a concave up parabola. So it'll open up. If A is negative, then it is concave down. So my parabola is upside down. So because A is -1 in this case, my parabola will be an upside down parabola. The H and the K is my vertex. And the H always switches signs because my formula is x minus h. So the way that I can get this to be x minus h is if this said x minus a -8. So here, my vertex for this particular problem, h comma k, is going to be -8 comma 74. I am going to have a normal width parabola, and it's going to be a concave down parabola. So what I have done for you on the next slide is show you when I type it into my graphing calculator what it looks like. Okay, on this slide what I am showing you is that I've typed into my graphing calculator -1 times, in parentheses, x plus 8 quantity squared plus 74. So you can see that I have a concave down parabola where my vertex up here is at -8 positive 74. On the next slide, I'm going to show you the exact same parabola, but I'm typed it in as my original problem. Alright, so you notice that this graph is the exact same graph as you just saw. However, when I type this one into my graphing calculator, I typed in 10 minus 16x minus x squared so that you can see it is the exact same graph, and you can also tell that you have completed the square correctly. Okay, here's just another example to show you on completing the square. So again, I'm going to start off in standard form, ax squared plus bx plus c. So this particular problem is already in that form. So 2x squared plus 8x plus 7. So again, the first thing I'm going to do is I'm going to rewrite it to ax squared plus bx equals c. So I have 2x squared plus 8x equals -7. Again, a must equal 1, and for our purposes, it is not 1, it is 2. So over on the left-hand side, we need to factor out a 2. So 2 is going to go on the outside, and when I factor out a 2, I divide both these by 2. I end up with x squared plus 4x, in parentheses, equals my -7. The third step is to take the middle term, divide it by 2, and square it. So I'm going to take 4 divided by 2, gives me 2, and square that, gives me 4. This is what I'm going to add to both sides. So on the left-hand side, I'm going to add 4 to the parentheses, and on the right-hand side, I also have to add 4. But remember that if you had to factor something out, so in this case I factored out a 2, that on the right-hand side you add your 4, which is your b divided by 2 quantity squared, times the a that you factored out, times the 2. So this 2 right here is coming from what a that I factored out at the very beginning. So on the left-hand side, what I have here is I have 2 times x squared plus 4x plus 4 equals, on the right, -7 plus 8, which gives me 1. And then finally what I'm going to do is I'm going to factor on the left-hand side in the parentheses here my perfect square trinomial. So that factors into x plus 2 quantity squared. It's always the b divided by 2. And so I'm going to finally take the 1 back over to the left. So my function is going to be f of x equals 2 times parentheses x plus 2 quantity squared minus 1. And that is what I would graph. So that my particular parabola would have a vertex of -2, -2, -1, sorry, that's my vertex. And this would be a right side up parabola, so it's going to be concave up, but it is going to be stretched. So it's going to be a narrow parabola, and I know it's stretched because the 2 here makes my parabola more narrow or more skinny, if you might want to say.